Okay, today we're going to be looking at domain of relations. And in order to understand the domain, I want to introduce this example with cash. Suppose that you only had $20 in your pocket. That means that you are only able to spend up to $20. If you're hungry, you could definitely go eat at McDonald's with $20, or you can go eat at Subway, KFC, etc., etc. If you go shopping and there's an item that you like that is $7.50, that means that you can afford that. If you're trying to buy something that's $25, then you're not going to be able to afford that because you only had $20 to begin with. You can represent the amount of money that you have with this inequality. You have from 0 all the way to 20. And this inequality here represents the amount of money you have in your pocket. And you can spend up to $20. So you can buy anything that's within this range from 0 all the way to $20. Now let's say that you go to the bank and you get a debit card. And then when you have a debit card, that means that in your pocket, if you have that card, you technically have all of the money inside of your savings account. So now you have access to the money in your bank. So you not only do you have the $20 in your pocket, but you have $500 accumulated in your bank. So now you can buy that item that was $25, or you can buy anything that's within this range. So as soon as you get that debit card, you can see that your domain got extended from 0 now all the way to 500. So you can buy anything within this range. You can say. Now let's say that you go to the bank again, but this time instead of getting a debit card, now you get a credit card. Okay, and when you have credit, you can technically spend money that you don't have. So you have a credit of up to $1,000 here. So here, now your money, or the amount of money you can spend, is from negative 1,000 all the way to $500. Okay, and that's basically the concept of domain, getting a specific region. And we want to apply this concept to the relationships that are being represented by graphs. We want information of specific regions. So let's take a look at an example. But actually, before we look at that example, we gotta establish some conventions. And here's your integrated math 1 review, repeat and review. When you have an inequality, if you have a closed circle, you're going to use these alligator looking symbols with a bar underneath them. If you have an open circle, then you're just going to use the regular alligator symbol with no bar underneath them. Now when we look at the domain, essentially what we're doing is we're getting all possible x values. So for these problems, we're going to be focusing on the values of the x-axis. So we're going to be looking at the x-axis. So we're going to be looking at the values right here that are located on the horizontal line. Let's take a look at an example. So here, example 1, we want to write the domain of the given relation as an inequality. We have this graph right here in blue, and now we want to get the domain of this graph. We're going to do so by getting the endpoints. Okay? And by endpoints, I mean getting the point that is farthest to the left and getting the point that is farthest to the right. And then we're just going to write it as an inequality. Scanning my graph, I can see that the point that is farthest to the left is this one right here. And we have a closed circle. So here I'm just going to represent this with a vertical line, and I'm going to slice through this hole with a solid line. Whoa, solid line right there. Now if I take a look on the right, I can see that the point that is farthest to the right is right here, this open circle. And I'm going to represent this by cutting it with a solid line. So here I can see the cut going through this point. Now you can see that I've created a region. My region is from -3 all the way to +2. That's where this graph exists. So my endpoints, again, we have -3 on the left and we have a +2 on the right. Now I want to represent this using an inequality, and here's how we're going to do it. I'm going to use my variable, and now I have to specify the lower bound and the upper bound. And before I go ahead and do that, let's take it a step back. And remember that we established that whenever we have a closed circle, we're going to use this alligator looking symbol with the bars below it. And when we had an open circle, we're not going to specify the bar here. This is called a greater than or equal to. This is called a less than or equal to. This one is just greater than. This one is strictly less than. So let's go ahead and specify the interval. On the left, we have a -3. On the right, we have a +2. So we're going to write -3 on the left. We're going to write +2 on the right. And now we're going to specify the lower and upper bound using these symbols right here. -3 is closed, so we're going to use a less than or equal to symbol. +2 is correlated with an open circle, so we're just going to use the less than symbol. And there you have it. This is going to be the domain of this graph from -3 all the way to +2. And this is the domain of this graph right here, where this graph exists, technically speaking. And now pay close attention to the variable I chose. I specifically chose x, and that was on purpose because these are your x values. Meaning that whatever x value you get here, it should give you a y value. But the only x values you're allowed to choose are inside of this region from -3 all the way to +2, not including 2 since I don't have that equal to. But we'll practice this a bit more as we continue to move forward. Now let's apply this with one more example. So now here, the same instructions, we have to write the domain. We have a graph that looks a little bit different, but the rules are the same. We have to get the point that's farthest to the left, and we have to get the point that is farthest to the right. So if I quickly scan this graph, you can see that the point that is farthest to the left is going to be this one right here. So let's go ahead and slice it. We have an open circle, so I'm going to slice it with a dotted line here. And we see that the x value that corresponds to this open circle is -3. So let's go ahead and write that down. Now we have to find the point that is farthest to the right. I immediately look at this point, but remember, this is not the point that is farthest to the right. The one that's farthest to the right is going to be this one right here. And let's go ahead and slice this as well. I'm going to slice it using a solid line because this is closed. And I have that right here. And you can see that the value that corresponds to this closed circle is +3. So let's go ahead and write that down right here. Now we want to specify this region. We want to specify the domain. And we can see that the domain is from -3 all the way to +3. So that's going to be my my lower bound and my upper bound here. Let's express this using an inequality. So we have -3, we have +3, we have x. Now the -3, remember that was associated with the open circle, so we're going to use a strict inequality. The +3, on the other hand, that one was correlated to a closed circle, so we're going to use the less than or equal to, and that is the domain of this graph.